Hello, everyone. Good morning. Hope you enjoyed the keynotes from this morning and you will have a good time at DevOps. Thank you for coming to my talk. It is going to touch a few sensitive subjects about HTTPS, using HTTPS, mutual authentication, and many more at application and infrastructure level. Hope you'll enjoy it. And I'm looking forward to your questions after the session and to discuss more with you about what I presented here. So first of all, about myself, I'm Anna. I'm currently working as a developer advocate for Oracle. But I am passionate about solving scenarios that are a little bit more complex, that involve Java, frameworks in general, and Kubernetes. Today's talk is going to combine the both. And we're going to see how we can use HTTPS and some security practices at application and Kubernetes level. Now, throughout time, in order to implement security for a solution, a software solution, we have debated for a long time. Should it be at application level? Should it be infrastructure level? Everybody agrees probably with both, right? Who's for application level security? Please raise your hands. Okay. And for infrastructure? Okay, good. So we kind of have an equal division of responsibilities because it should be in both places. We should care about those in both places. However, we can ease our life by implementing certain things at infrastructure level rather than to encapsulate them at application level. And the talk of today is going to talk about this kind of solutions, about these kind of gateways for our Java applications, how we can build them. So from my point of view, a security gateway must have what that solution should be about. Should be a way to quickly set up a connection, a way to connect the environments, the place where when I'm running my applications, manage the mapping maybe between the local or the remote, and of course, prevent any unauthorized access by allowing or denying access on a per resource basis. Of course, it would be great for my solution in this century to be all the time available and also support the load and not have a lot of lag. And of course, we don't like when our applications go down. And of course, it should permit encryption and authentication. But moreover, for me, this thing is going to mean to allow an easier way to maintain encryption, authentication, working with certificates, than doing all the time manual tasks. And of course, monitor traffic, because I would like to know what's going on with the traffic that's incoming to my application or is going from my applications. So we're going to all the time look at these must-haves throughout the presentation and see how well they're satisfied by different ways of implementing this. First, let's talk about mutual authentication in Java application. Mutual authentication, or the two-way authentication, refers to two parties that are authenticating each other at the same time. And sometimes this is the default authentication mode in some protocols, like SSH, or optional in others. Now, mutual TLS refers to the transport layer security that uses a two-way encrypted channel between the server and the client. And this is the overview of what we're going to discuss today. So what I'm going to apply some topics of today. So I'm using a browser. I need a client certificate, of course, to access my front end, which is developed with Quarkus running on JDK 20. And of course, front end asks some information to the backend, which is done with Helidon, also running on JDK 20. So what I'm using in order to make sure that I'm allowed to see information in my front end, but also access information from the backend, I need a way to place the certificates and make the both application see each other and allow each other to read information or to send information to each other. So we need the Keystore and the trust stores at each level for mutual TLS. Moreover, if you're looking further to this, we need the Keystore and the trust store at each level. But how that goes? It happens the front end is the one going to the trust store of the backend for the client authentication. And then the server authentication happens from the Keystore of the front backend to the trust store. Who knows the difference between trust store and Keystore? Yes, in front. say it.
Keystore is for keeping the private key of this part, and trust store is for verifying the keys of the other part.
That's great. So the answer that I received, it's a great answer. It's a perfect one. So the trust store is used to store the certified authorities, the CA certificates, those ones that are verifying the certificate presented by the server in the SSL connection. And the key store is used to store private keys and identity certificates presented to both parties, server or client, on a program verification. So for my demo, I have created my own certificate authority because I wanted to have a way to simulate a trusted third party that issues digital certificates, right? And I want to work with that one. So in my case, I just use OpenSSL. Because I have Mac, I had to use minus extensions v3_ca. It's an issue with an OpenSSL default that I can tell you about later when that is being generated. And I created myself certificate authority key and certificate authority certificate ca.crt. I'm going to use this further for this command. And this is the output, right? So I'm going to store this in CA, CI_crt, and ci.key. Now what I need with this certificate authority is actually to set up my key stores and trust stores for both applications. So what first I'm going to do, I'm going to go and generate my client key. And I'm going to use the common name, the name of the fully qualified domain name for my application, which is client.company.com. When I'm going to create this certificate. That's going to be very important later on when I'm going to deploy in the Kubernetes and so on. Give an alias to this key. I'm going to say client because it belongs to the front end. And just to make it a little bit more different, I chose to have the store type JKS, like the Java key store, for this key store. Nothing fancy so far. Now I've generated the key, I need to sign the key. So I need a certificate signing request. What this certificate signing request is a message sent from an applicant to a certificate authority of the public key infrastructure in order to apply for that digital identity certificate that I'm going to generate further. So I need this for my own certificate. So once I did this, I've generated my CSR for the client key store. I can go and sign the certificate for my client, the one that I'm going to use for my key store. And you can see here that I'm using the CI_crt, the certificate of my certificate authority, use the key of my certificate authority, and of course, use the previous created certificate signing request to generate a client.crt. And once I did this, I can import my client.crt to the key store, and that's it for the key store setup. Once I have this, I can also import the client certificate to the CA trust store, where I want to store the certificates for the trust store. But that's an optional step. It's not mandatory. And my final setup for my Quarkus app is going to look like this. It's going to have the key store configured for my front end using the client.keystore, the JKS one. Now for the trust store setup, it's a similar setup. The only thing that I did with the key tool generation is the fact that I said, okay, generate this with server named server.truststore. And because this is going to be used for the server authentication, I'm going to use the server.company.com. Again, creating a certificate request, signing request, and signing the certificate using a certificate authority with it. Import and have it done. Now, the overall look is like this. So you just have to know where this is, because I'm going to explain which was mapped further in the configuration of the file. So if I want to have this done at like HTTPS at the application level, I need these two, ideally, the client key store and the server trust store. And of course, I need a setup. Like at Quarkus level, I just enabled HTTPS with Quarkus HTTP.SSL port. If you want to disable the traffic on HTTP, you can set the HTTP port to 0. But in developer mode, you can still access that one. Just not be scared that you can still access it in developer mode. Then I set up the SSL protocols and, of course, the Keystore files and everything. And you can see here that my Keystore password is set in clear. Well, that works for local, right? It's great. But what happens if I need to go to infrastructure? Okay, we'll talk about that in a moment. Now, similar setup for the backend with server Keystore and the client TrustStore, because remember, we need both in the mutual TLS. And because my backend is in Helidon, I need to configure this in application.yaml. So it's a slightly different situation than in the case of my front end. So in case of my Helidon config, if I'm working on local, I can use the class path. That's what resource.minus-path means. You can use the class path, like have the Keystore maybe in the class path in your local. But if you're working in a deployed environment, you can just say a location with location path. So just replace this with location path and it will be okay. That's what I did for my deployment so that they would work. So this is my final setup, and this is how things are working, right? Okay, so let's look a little bit to my application. So I have my Quarkus set up in here in front end, my application.properties, my Keystore, TrustStore, they reference some stuff on my local. Also my Helidon setup, just to make sure that I'm using the right things, with the resource path to the server Keystore client TrustStore, and let's set up them. So first of all, Java 20, MVN Quarkus dev. Let me restart the main here. Hope that internet is working properly if I need to download something from the internet. Okay, this one started. But locally, I don't have a storage, so I'm just going to port forward where I'm storing my information from Cassandra. A second. Come on, internet. Yes. I was worried for a moment that it left me. Okay, forward ports on 9042. So I need this just for the, oh, I was talking without showing you anything. I'm sorry. Please shout next time. Okay. Let me make this bigger. I'm sorry. Let me do this again. So I was talking without showing you anything. So let's start the Quarkus app, nvm Quarkus dev. And I'm running my Helidon app from main, just running like a like you're running the Spring Boot app similar to this one, and that's it. Now, one thing that you should know, the Helidon app is running on port 8854, and the other one runs on 8443, if I'm not mistaken. Let's go to a private window and say localhost 8443. Let's go with the Quarkus app. Okay, because it's my certificate of authority, it's interesting. And you can see here the certificate that I've generated with the previous commands that runs on my client. This is the client certificate, right? Accept and continue. Good. Now let's go to the server. 8854 happy backend. New my certificate. And this one has server.example.company in the server. But completed, clear completed. To do I speak at Devox UK. And you can see all and the active one. Next. So the application is running okay with the generated certificates that I had earlier, and it's great for local. However, if I want to move this to Kubernetes and like have it deployed nicely, the simple K8s pass-through that I imagined, it would look like this. So it would be my to-do front-end having a deployment resource with a service, and to-do back-end with a deployment resource and the service associated to it, maybe an ingress before that. Then I need to overwrite my application configuration, and I can do that from a config map called frontend app config and backend app config. That's great. Then I can store my key stores and trust stores in a volume or a secret because they're files, and I can create those from files. But that's a lot of resources to be thinking of and to manage. And the question that probably many of you are thinking right now, okay, you created the certificates, you created the key stores, but those will expire. I mean, certificates will expire at some point. How are you going to maintain that? You're going to create again certificates, go and import them to the key store, copy those in Kubernetes, and restart the deployment and so on. That's pretty much complicated. And as a developer, probably you're thinking like, that life used to be simple before this. And maybe there are a few things that can be simplified around working with certificates, at least. So if we're looking at the solution that we have so far, we have securely connected to environments. We allow encryption and authentication at application level. But there are some things that are not so great, meaning, well, we can allow or deny access to resources at application level. But we cannot, we're supporting load balancing and high availability, but with regular vanilla Kubernetes resources, which is good up to when actually you need more routing. And monitoring the traffic with basic infrastructure that you have available at Kubernetes. So there are things that can be improved. But first and foremost is like maintaining those certificates, how you can maintain those in a simpler way and not all the time create them manually, copy things in Kubernetes, and so on. So you can automate certificate management with Cert Manager. What Cert Manager is a cloud-native certificate management service for Kubernetes. So you can add resources, add certificates, and certificate issuers as resource types in Kubernetes. No longer have them, maintained by yourself in a volume or a secret. It's easier to work with certificates with the Cert Manager, because it can also automatically renew certificates. As it works inside Kubernetes, it can remember when it should validate your certificate or let you know that it should renew a certificate because that one expires. You can approve or deny certificate requests using Cert Manager CLI. So for example, there are situations when you want to say this certificate that was issued by an application, you don't want to no longer accept requests from that application. You can remove that certificate, revoke that certificate, even though that one didn't expire. You don't have to wait for that one to expire. And you have to be aware of what you should deny into entering your application. So having this installed via the static file or via Helm charts, it can help you work with certificates. And let's see how we can do that. Now, you can represent certificate authorities with Cert Manager. There is something called issuer and cluster issuer. Issuers are available at namespace level. So if you want to have different issuers for different certificate authorities across different namespaces, you can do that. Like, for example, if you're working with Let's Encrypt, you know that there's Let's Encrypt staging and Let's Encrypt prod as a certificate provider. So you can do that between different stages. But you can also work with cluster issuers, like issuers that are available at the cluster level. Or if you have Vault, you can integrate that one with Cert Manager. But in my case, I wanted to reuse my certificate authority in Kubernetes. So what I did, I created a secret, the CA key pair, from my previous CA certificate and CA key. One thing to know about is that because you're creating a TLS secret, and my OpenSSL command that I used to generate my certificate authority certificate, created an encrypted key. So you need to decrypt that key. That's why I passed for you the command on how to decrypt the key and pass that to the secret. Otherwise, you're going to receive an error from Kubernetes saying that you're using an encrypted key to create a TLS secret. So once you have created this issuer, you can use the issuer to actually make your own certificate. And the certificate usually looks like this. It's kind certificate, and in the secret name contains the name of the secret that will be auto-generated and contain the TLS key. And of course, it also has to be valid for an issuer. So for the issuer we created earlier. So you're going to use the CA issuer at the CA issuer ref. Moreover, if you need to add key stores, you don't no longer have to worry about creating or maintaining those yourself. You can specify the key stores and say which type of key store you're using, JKS or PKCS 12, and that can be created automatically for you and will be stored under it'll be stored in the same secret name as you guys given in the beginning in the specification, like in the front end -TLS in my case. So those are automatically created, but there are two things that are not automatically created and you have to do with Cert Manager in this case. You have to be the one who's creating the secrets that will hold the password for your key stores. So you have to create those prior to doing the certificate. And you can do that like in the example here, generic, or you can encrypt them for them. How that looks now. Okay. Now the key store setup will look something like this. Okay, I'm going to mount my secret to volume TLS. And it's going to have the secret name FrontEnd TLS. That's going to be automatically created and maintained by the certificate manager certificate. That's cool. I can override some environment variables for my secret key ref, for my trustword password and keystore password. Great. Keeping the config map ref. But this seems, again, like too much YAML to be maintained. And too much complexity, even though that we added Cert Manager. And how do you know how to create the right certificate as a Java developer? So probably you're like thinking, how can I use something else to help me with Cert Manager and generate some YAML for me? Now, you can add Cert Manager via Dekorate. There's an extension in Dekorate that works with this one and can generate certificates for you. So Dekorate so far is a tool that can help you to generate Kubernetes manifests. So if you want to generate deployment services and other Kubernetes resources, you can do that by annotations or properties. And moreover, you can add Cert Manager extension to that, and that one can generate for you certificates. So you don't have to manually create the YAML that I showed you earlier. Let me show you how we can do that. Let me say escape. Moving here. Okay, so let's look further, first of all, with annotations. So what you need is the annotation at certificate. Let me see. Oh, I should make this bigger a bit. At certificate. And I'm going to have, I need a name. So if I want to make the same thing, because this is the backend, I can say backend cert. Mandatory is to have a secret name, which is, in my case, backend TLS. What else do I need for this one? Of course, DNS names, if I really want to be thorough. But I need the issuer ref. And I can do this by saying issuer ref. And the issuer ref, actually, let me go to the actual Case Manager, backend certificate. Okay, split and move right. So this one, I don't know by heart. So I just need the same thing as here. Okay, name is going to be CA issuer. And then, let's say, kind, in my case, is issuer, then group, Cert Manager, .io. Yeah, that should be enough from my point of view to generate this one. Okay, so I go to backend, clear Java 20, and just say mvn verify. Now, it will not create the exact secret, but in the repository, you have the entire specification on how to create the secret exactly like before. So let's go to backend, target classes meta-inf decorate kubernetes.yaml. And because I have Dekorate also for my deployments and services, also generated that for me. And I'm just going to scroll down to the certificate and split and move right. So my certificate, of course, is called backend CRT. It has a secret name called backend TLS. It has the issuer that I wanted. It also tells me about the keystores and JKS or PKSAS 12, so it generates a few defaults for me, which I can override from my annotation. Moreover, at Quarkus level, of course, I can do this from properties file. And at Quarkus level, it's mandatory to give a certificate name, like in FrontEnd CRT, FrontEnd TLS, the issuer like before. And if I'm looking in target Kubernetes, again, my certificate is according to my expectations. And because I configured also the namespace is going to apply to FrontEnd CRT as well. So this way I can generate those much easier than all the time going to YAML and configuring those in YAML. Now the front-end and Keystore and TrustStore setup look like this. So we kind of automated this, secured the part with the certificates. Okay, we're mounting the front-end TLS secret that's maintained by the secret, so we're not maintaining that many certificates manually ourselves. However, we still need to pass the passwords and override a few configurations that we have, at least at front-end level. Let's assess again the security gateway checklist. And, well, the security gateway checklist now, security connects it to environments, allows or denies accesses per resource basis, permits encryption and authentication, but still the load balancing, high availability, and monitor traffic are basic infra. And let me show you a bit where I have my apps. So kubectl get SVC and access the applications that I have on my front end. So I can just, go through the external IP. Yes. And because I'm using the same Cassandra database port forwarded to my local, I already see what I had before in my local. So another to do, and that's it. However, I configured quite a lot just to do this. I simplified the certificate management, but still there's quite a lot there to be configured. Let's see how we can simplify this. So that's where the Istio is coming into the equation. And we're going to look in how to enhance this pass-through setup with Istio Gateway. So first of all, the advantages of Istio and why I chose it, because it allows traffic control. You can change the routings much easier because it has gateway resources. You can have service resiliency, so you don't have to all the time think of resiliency at application level. You can externalize that at infrastructure level and just deal with that there. And of course, Istio CLI is great because it has integration with Kiali, Prometheus, Grafana, and more. So if you have installed Kiali, Prometheus, and Grafana in the same cluster, you can just say Istio CTL dashboard Kiali, for example, and you get access to the Kiali, showing your resources and what you have done correct or incorrect with Istio in your setup. So, I don't know, hope it's visible up in the back. This is quite a complex picture, but what we have here is how the pass-through TLS works with Istio. So everything, of course, is being controlled from the Ingress controller and the control plane API. When a request is coming, that request is there interpreted by the gateway resource that configures a load balancer at the edge of the mesh to receive incoming HTTPS traffic. In our case, it's HTTPS. But because you also need a way to direct the incoming traffic to the right application, and we already had some services defined, that's why we're going to use a virtual service. That's what front-end virtual service, I hope, is visible to the back. So the gateway is there to like firstly handle the request, but then it forwards that to the respective virtual service, which actually has the host of my service. Then my request gets to the right service on port 443, gets to the backend, gets to the front end. Now the front end, because it's running an application on HTTPS, of course, and it requests information from the backend, it sends back that, says like, okay, I need this from another app, but I need to make sure that I can authenticate against that one. So it comes back and looks at the backend gateway config that has, then the request goes to the backend virtual service, and service and deployment. So everything goes through the Ingress controller because I'm using the Ingress gateway to route my requests all the time. So I'm not using only the DNS available at Kubernetes level. I'm using just the Ingress gateway available at the level of Istio, which is much more elegant to use in terms of routing. How that looks like. So gateway in the pass-through mode, you have to specify the host. Remember that in the beginning we talked about creating a key for a specific host. Well, that key is going to play a major role here. The common name is going to play a major role here for our host. So we should think about our hosts for our front-end gateway when we are looking at the certificate CN naming, right? Again, we're using HTTPS. So you can see here the protocol is HTTPS and the port number is 443. But when we're going to forward this, we're going to use the mode pass-through. So what this means is that the TLS termination is going to be at the level of the application and is going to be passed by Istio to the, let's say, in the end application. It's not going to be handled at the infrastructure level. Next, once the request gets to the virtual service, this virtual service has to know from where it accepts those forwardings. So you should apply there the name of the gateway that should apply the routes. Let's make this a little bigger. And next, traffic is being sent to front-end service on port 443. So you should specify destination for the front end. And again, there is important to match the host on port 443, but also the SNI host. So the SNI host and the host have to be the same. Otherwise, you're going to have some issues in routing your requests. And that's where most of the troubles are coming from setting up things. Now let's look at the current setup checklist. We can securely connect environments, application and infra. We can allow or deny requests on per resource basis at application and infra. We support load balancing and high availability thanks to Istio. And now we kind of delegate that at the infrastructure level. And it's much more thoroughly than the basic Kubernetes one. We can permit encryption and authentication. I should have modified this one here. It's app and infrastructure, and mostly is infrastructure. Sorry for the typo there. Because the certificates are being handled and rotated by Cert Manager. But not only that, we have the app that is accepting those and looking at those there. And you can monitor the traffic at infrastructure level better, thanks to Istio. But there's a better way. I'm not sure better way. There's an alternative to this. So if you want to use HTTP at application level and just have at network level mutual TLS, Istio's coming by default with that. So Istio's by default mutual TLS. So you can just have HTTP in ports configured in the application, like 8080 all over the place, and handle everything in traffic at the level of Istio. And how that would look like. So that would look like in the following picture. The request isn't coming, and because Istio is automatically configuring workload sidecars to use mutual TLS when calling other workloads, the request is going to be again passed to the front-end gateway. But in this case, we're not going to reference the certificates anymore in our deployments. We're going to reference them at the gateway level, and we're going to see that in a bit. We're going to reference the certificate manager there, the certificate manager certificate there. So it comes to the front-end config on the port 443. goes to the virtual service, and hope that this is visible to the back. The virtual service has port HTTP 80, so there's no any more need of HTTPS 443 and all the other stuff. So we can just go with 80, and then the same things, forwarding to service, going to the backend, and so on. And similar things apply to the backend as well. How the front-end gateway evolves. The front-end gateway now changes mode to mutual, and because we have to reference the certificate that we're going to use in this mutual TLS authentication at infrastructure level, we're setting up the credential name that we have created before with Cert Manager, like FrontEnd Cert, there in the credential name. And of course, we still keep the HTTPS configuration in the other parts in the same host. Okay, should have made this bigger. The front-end service, virtual service, now it becomes more familiar for HTTP routing, and it's easier to look at it. It has, the same gateway, but is using port 80 on HTTP. So you can see that things have changed here from TLS to HTTP, and the route is to the service front end. Okay. But you can enforce mTLS at level of Istio. So I said that by default, Istio is coming with mutual TLS enabled, but that policy is called the permissive mutual TLS, and I'm going to explain a bit about it in a short moment. You can set mutual TLS to a stricter mode, meaning to allow only encrypted traffic between your applications. So you don't allow any plain text traffic between your applications. You can set this mutual TLS specific to service. You can specify it by specific to a service by using selector and those match labels there. You can set it only for a namespace, so just remove the selectors and just have mTLS mode strict, and you set it for a namespace. And if you don't specify any namespace or any selectors, that will be applied wide mesh. So be careful with that, because you're going to be very strict with your setup the entire service mesh. Moreover, made this a little bigger. So this one is actually restricted at the demo application level, but only for my services front-end and Helidon apps examples to do back-end apps, because I want for the other ones not to have the strict application applied to them. There is a catch with choosing Istio and TLS mode. So, as I said, Istio configures each proxy that is there in the pod to use mTLS in a permissive mode by default. So this means the service will accept both plain text and mutual TLS traffic. That's great in the permissive way, and it's great, by the way, if you're trying to migrate something. But if you're putting all the time strict, that will allow only encrypted traffic. And if, for example, you have Istio configured only for certain namespaces, but you have deployments of applications in other namespaces that don't have sidecars, those applications will not be able to authenticate and to use your applications that are deployed in a namespace that uses Istio and has the strict mode enabled. So be careful with that, because it's going to pose some issues if you're using strict mode all the time. So now let's look at this security gateway checklist in the final one. We can securely connect our environments, and we can do this at infrastructure level, and we are looking at overriding configurations at infrastructure level. We can allow or deny access as per resource basis, but not only at application level, but we can do it at infrastructure level thanks to Kubernetes. Then we can support load balancing and high availability thanks to Istio. We can permit encryption and authentication mostly at infrastructure level, because we're using a Cert Manager to rotate our certificates and to make sure that they're perfectly fine. And we can monitor traffic again thanks to Istio. Moreover, there's some takeaways that I want to have from the session. I'm not sure if it's visible in the back, but I'll share the slides. If you start at application level, like I did, and I'll share the code, by the way, both the server and the client should authenticate each other for more than robust security. So it's for mTLS. With Cert Manager, as I told you, you can like automatically manage your TLS certificates and rotate them. If you are a Java developer, you can use Dekorate to generate the certificates, so you don't have to all the time write YAML. That can be generated. You can configure mTLS in pass-through mode, but you should be aware that in pass-through mode at Istio level, you're passing the traffic to the destination service. So without Istio, we were still using a pass-through, but only Kubernetes. And we were, again, passing the TLS traffic to the destination service. But with Istio is much more visible because we have the mode pass-through specified. And a strict mTLS mode will allow only encrypted traffic, but pose issues to those pods that do not have proxies or sidecars that can send encrypted data to the other applications that are running under the strict policy. That was it. Thank you very much for listening to me. I'm welcoming your questions. This is where you find all the code and the setup for everything with simple Cert Manager and then Istio with Cert Manager and the other stuff. So, thank you. And I know it's quite a lot. It's more code in the repository, but welcoming your questions and yeah. Everything was clear. Wow. I mean, mutual TLS or security topics usually are very tough, but we can. Oh, yeah, cool.
Just a quick one around. Just around the Cert Manager and reissuing certificates. So, say, I mean, you had 365 days, for example, of expiries. Presumably, with these solutions, you have to roll over or re-roll out all your services. As the certificates expire, Cert Manager won't dynamically change whether it's through Istio or whether it's built into the app. Is that fair? So as the certificates expire, you want to roll out a new certificate, your services have to be redeployed?
Since the certificate will be rolled out again and reissued, I think you don't need to redeploy the service if you're using the credentials set up at the level of Istio. But if you're using the other thing, the pass-through, and you're setting everything at the level of the deployment, yes, you have to roll out the deployment again so that they take into account the new configuration. Yes. Any other question? Yes?
First of all, great presentation. Thank you for that. My question is, can we configure the algorithm to encryption for encryption, like what algorithm we're using here, and can we configure anything apart from that, like where those configuration will go? For example, it is using SHA-126 or something. So can we configure somewhere those algorithm, which one to use for encryption?
The algorithms used by encryption. You can configure the algorithms when you're generating the certificate. So when I use KeyTool to generate my certificates, I can choose and pick and choose the algorithms that I want to use. I didn't detail a lot, but the reason why I prefer KeyTool most of the time is because it gives me a warning if like an algorithm is unsecure anymore and tells me like this is not okay to be used anymore. And in the JDK, for example, I know that some algorithms have been disabled so that you cannot generate certificates with those anymore. But it's the level of the certificate manager. When you're creating the certificate resource, you have a way to give the algorithm for the private key. So you can say it's RSA, it's PKCS1, and I think PKCS8. I don't remember. There are like 3 types or supported right now in the generation that I saw there, or 4, 100%. But you can do that at the level of the credential as well, for the certificate manager. So you can configure that too. Yes.
This might be a stupid question, but when I've had a quick look at Istio and the mTLS point-to-point, I had to do injection. I had to configure the injection of these sidecars to set that up. Is that, when you set that mode to mutual in your configuration, is that effectively the same as configuring with like annotations and things like that?
So if you have, from what I remember, if you want to have the sidecar automatically injected, you have to set it as enabled through the annotation. So there is in the documentation of Istio how you can set that one as always enabled, so it's that. And I didn't have any issues after I set up the mutual, but yeah, I always have them automatically enabled to make the sidecar proxies for my. It's actually a very important thing to do with Istio when you're installing it. So not just install it, also label the automatic injection if you want. It's not a stupid question. It's a good question. And yes?
Notifications, does this Cert Manager give you notification when the certificate is about to expire or something?
So I hope that I'm. So it has I think it has an admission. I'm trying to think about which type of controller is using inside of Kubernetes. So I think it has an admission controller in Kubernetes that is watching over the resources, and that one is actually keeping an eye on the resources to make sure that it renews them when they expire. Doesn't give you a notification, but talks with the Kubernetes API. So probably if you're like gonna inspect and if depending on how you set logs on your master, you're gonna see something log that there's not that there's been a renewal of certificates happening there. So most of the time, Cert Manager is a Kubernetes add-on. It will notify the Kubernetes API, not necessarily you, but you can like have an alert if you're following those logs or something like this from there. So it's not welcome. Any other questions? By the way, I love your t-shirt. Yes?
Presumably, it doesn't have to have the certificate issuer set up within Kubernetes. Like, at our organization, at least, we have to go off to a specific team and send the certificate signing request to them. Like, we could just take the files and pass those into Cert Manager.
So you don't have to all the time set up the certificate yourself. I think Certificate Manager has already some integrations with other providers, but I didn't look that thorough. I just picked up this one because it was connecting better what I did at the application level with my certificate authority to migrate it upper at the infrastructure level. But you should check the documentation for Certificate Manager because they do say that they already support a lot of integrations out of the box, so you don't have to do a lot of work. And it's quite cool that it works with Helm charts, so you don't have to manage that all the time yourself. Any other question that's fallen to somebody's mind? Well, in that case, you will find me throughout the conference, so stop me and talk to me. Would love to hear back from you. And enjoy the rest of the conference. It's going to be great. Thanks.